Hello, everyone. Welcome to Wind Down Friday. Today, our distinguished guest, expert in power systems, is Pietro Scalia, Head of Power Business Development at Renesas Electronics. Ciao, Pietro. Welcome aboard. How are you?
Thank you, Maurizio, and I'm very good. And first of all, thank you for guesting me in this wind down session and having some, let's say, relaxed environment to talk about power, of course, at Renesas.
Yes. Thanks a lot for being here, Pietro. So, we talked a lot during your previous companies about wide-band gap, in particular, gallium nitride and silicon carbide. So, to kick things off, let's dive into the technical side. So, let's share your consideration, comment about wide-band gap to our community. What are the key advantages of wide-band gap components over silicon-based solutions? Where do you see opportunities if you should choose just one, GaN or SiC?
Yeah, first of all, I think wide bandgap is really changing. I think the power arena now in the last 10 years, it's already enough time, but on the other side, still these two technologies are immature, of course. And I mean, if you think about IGBT, it took about 40 years, right, to establish. I think we are already pretty far, I think, in deep. Let's say in a very nutshell, talking about application, because of course I'm always focusing on solution.
Mm-hmm.
The main benefit of the technology, I would say, I would divide into three pieces. So the first piece is, of course, the high voltage application, right? So the wide bandgap, which is there is this magic factor of 3, right, versus silicon enables basically to go easier to voltages which are able to, let's say, be applied to energy generation, to storage, to a lot of applications across high voltage. I think the second one is, of course, the high switching frequency, which is, let's say, enabled by the high electronic mobility and let's say velocity. And I think the combination of both sees GaN as the fastest, right? Silicon carbide is the second one ranking versus silicon. And I think the third element is, of course, temperature, right? Temperature is very important, especially when you need to get to very high density.
Mm-hmm.
So a better conductivity of both materials, and in this case, silicon carbide is the king, right? Enables specifically for very high power silicon carbide to be the choose and the possibility that designers have. If I have to pick one opportunity, of course, it's a bit difficult, but I think let's start with silicon carbide because it's more mature. It's already reached a significant amount of business in the market. Is projected basically from 4 billion to become 10 billion in the next 6 years. I think, of course, EV traction, right, which has been my passion for the last few years, is the king application at the moment, also in terms of numbers, because, of course, the modules guess a lot of dies, right? And then if we go to gallium nitride, it's more difficult because the business is still pretty small, right? It's about 1/10 of silicon carbide, but on the other side, with a CAGR much faster, like actually double than silicon carbide. So it will recover. And it will get about a couple of billion, probably between 2 and 3 in the same amount of time from now. And if I pick one today, it's definitely consumer, right? So it's this AC/DC for different applications from portable, let's say, chargers up to 120 watts, or this laptop up to 300 watts. It's really enabled. I have, to be honest, big expectations for infrastructure as well and energy, because infrastructure is a lot of server needs now with the new GPUs demanding so much power. The rack will increase dramatically the power inside, and I think definitely gallium nitride will make a big difference in AC/DC portion of data centers.
Thank you, Pietro. So speaking of challenges in your field, in your professional career, can you share a moment, a recent challenging power system issue that you encountered and how you solved, how you and your team solved this issue?
Yeah, let me say, of course, for what we can reveal, definitely still remaining on the wide bandgap, right? I think today one of the interesting topic is about mixing the two technology, silicon and silicon carbide, for example, at high voltage, right? We live still the decade of IGBT, right? It's still the majority today of the selling. So I think the idea is how much silicon carbide, how much IGBT should I put, for example, in a traction inverter? Eventually, I can combine the two technologies, right, to make the best match, let's say in hybrid concept, right? So we have elaborated a lot on this. This helped us, for example, to also resolve one topic on the diode to be the FRD to be associated to the IGBT, which plays a key role for switching performance. So I think this is a topic that we will explore more at Electronica in the next trade show coming in Munich in November, and I think our customers will be excited to see the results and save also some dollars on the bill of material.
Yes. So on a lighter note, just to stay on philosophy of Wind Down Friday, let's talk about life outside of work. So we want to know more about Pietro Scalia hobbies, activities, extra activities outside your work, maybe with a good wine. So tell me more.
Yes, I think the wine is, of course, part of that, but I think I'm a very sportive person. So I spend my time with two main sports. I think tennis has been my life sport and volley. More recently, beach volley, because in Munich, we enjoy a lot of these facilities, even in winter, right? We can play indoor. And this is something that also brings together with other people in a good team spirit. And I think these are my two passions on top of playing guitar, which is also, I think, of course, a very long, let's say, when I find the time, I think still
that is a problem.
Of course. Yes,
Which
this
is
is
your tennis player, your favorite tennis player?
Definitely Roger Federer is now retired. Definitely is the king or maestro, as the people like to call him, even in Germany. And of course, we are excited about the young Italian boy, Yannick Sinner, who is actually playing. And by the way, the maestro recommended Yannick when he was like 17 years old. So probably he knows where the talent stays.
Nice. Thank you, Pietro. So, Pietro, talking about business and the future. So looking ahead at the industry futures. So how do you see the market, the power semiconductor market evolving in the next years, maybe in the next few years, especially if we consider the rise of AI and electrification?
Yeah. So first of all, we have these mega trends, right, that are boosting our market. We live at 2024, which is definitely not the most exciting year, right, with the market a bit flattish. But on the other side, the mega trend of AI is creating so much demand, right? If you think about, we are talking now in terms of, say, increase of power basically by a factor of 4, right, per rack. And this is an incredible challenge. Where I see now the differentiation that companies can bring to the table. This is not only about technology. We talked about wide-bandgap, of course, but for example, pillars like packaging, right, is becoming extremely important. For example, in vertical power to support the GPUs, right, power cannot be conducted in a conventional way. It needs to be brought on site just below the load. And this is a big challenge for everybody. I think the industry is right now working on this. There are good examples from some of our customers like Flex, Murata, Delta, but these are just the beginning of efforts. I think the problem is not yet solved, and Renesas is contributing, of course, in solving this. We have a great reputation in data center and multi-phase. And I think we are leveraging this together with our, let's say, over-the-top players and specific ODMs in the area. And we will work and we will show to customers some solutions coming soon. So it's a very exciting time where it's a multi-technology. I think dissipating the heat is very difficult. So I think the power density is increasing, packaging will help. And I think the high voltage bus can be the other important element into this game, because today, finally, we migrated to the 48 volt, right? After some time, OCP took some time to establish it. but clearly it's not the end, right? We know very well that many inside OCP are working on the 400 volt or even 800 volt bus, because this will reduce, of course, the bus bar in the rack significantly. So this is something that I think complemented by wide bandgap, which definitely will be applied massively there, and not only at high voltage eventually, maybe even at low voltage, below 200. I think this will revolutionize, I believe, the scenario. And of course, we know more about electrification because this is happening. I think the adoption in the market of wide bandgap is massive from the OEMs in automotive. And I think, yeah, the market is super exciting, and we will see the next 5 years for sure growing with a CAGR of 25 for SiC and 50% for GaN, which is again super exciting. AI data center power grows about 50% CAGR as well, which is, I think, phenomenal number.
Yes, thank you, Pietro. So in conclusion, so before leave you to enjoy your weekend, so last one, focusing on Renesas strategic direction. So what main strategic initiatives is Renesas focusing on this, on your planning to stay competitive, to stay ahead of the competition in the power solution market?
Yeah. Renesas is really, I mean, like the name says, implementing a renaissance, I think, in power, right? Acquiring so many technologies during the last few years and different companies, right, that brought this technology brings a very unique portfolio, right? So if we think about switches, right now we have basically all the technologies, right? We have PMOS, we have IGBT, we have GaN, we have SiC, of course, in different stage of maturity. But I think this great ingredients, right? This is how I like to call it, can cook a phenomenal cake, right? And I think this is what the company is doing right now. Establishing power is the second pillar after, of course, the digital, where Renesas has this unique, let's say, quality factor in the market. So I believe we come from a Japanese culture, which brings along quality and execution from a design perspective. And we are, of course, adding agility as the one in the background are talking about, and a very, say, smart entrepreneurial spirit, which is more American, I can say, to the game. So Renesas wants to be big in power, established supplier in power. And again, this multi-technology will enable. We can apply gallium nitride now from high voltage, getting, let's say, down to mid voltage, but we are willing to expand. And we are renovating our, let's say, PMOS portfolio because, of course, there are MOSFETs everywhere. And I think we offer basically a portfolio with DC-DC. We offer a portfolio with controllers, with integrated e-fuses, IPD, which is almost unique in the market. Not many companies have the same breadth. And we can attach basically all this power to our MCU proposals, to our MPU proposal, where we are definitely market leader among the few competitors. And I think the system approach that my team specifically drives, right? We believe in solution power, right? Solution means talking with customers to resolve their problems, right? Not proposing the single part, but proposing an array of parts where the customer can find the solution entire to the problem. I think this is very important also with hardware. You will see a lot of demos in the next trade shows, including Electronica, where we showcase basically the very important application, as we said, energy generation, energy storage, and the utilization like electrification in vehicles or let's say AI. And I think this is where the company will invest for the next 5 to 10 years. So this is a long-term game, and we want to run this marathon.
Thank you. Thank you, Pietro. Thanks a lot for joining us at Wind Down Friday. See you in the next conference, probably in Milan at Power Up Fortronic, our Power Up Fortronic. Thank you. Have a good weekend and talk soon. Ciao, Pietro.
Thank you again, Maurizio, for your welcome, and see you definitely in your event in Milan. Thanks again. Talk soon. Bye-bye.
Bye. Thank you. Bye.